London forces exhibited by non-polar molecules. What do you mean by non-polar molecules? When the atoms share electrons equally in a covalent bond, they are known as non-polar molecules. So here I have taken two molecules, that is molecule A and molecule B. Atom A and atom B. So in atom A and atom B, the electrons are present at the center first. Later what happened? The electron moves temporarily to one side. So here when they are moving to temporary one side, a temporary dipoles of atom A and B attracts each other. So here when the electron moves towards that side at one side, a temporary dipole will be induced. Okay, here plus is there, so here minus will be charged, means you will get a minus charge here. So this is moving this side, no? So here minus, this will attracted by this plus charge, and here minus charge. So these are temporary charges. So a temporary dipoles of atom A and atom B attract each other. Similarly, a temporary dipoles are introduced in the molecules. So this force of attraction is known as London forces. Okay, London forces or dispersion forces. These forces are always attractive, and interaction energy is inversely proportional to the sixth power of the distance between the two interacting particles. So look at here. London forces. What London forces? They are temporary forces. Why they are temporary? Because here charges were induced. So the electrons are moving one side. So when they are moving inside other side, so this electron comes towards this. So here this is plus is there. So here minus charge will be induced, isn't it? So due to this, a temporary attraction will be occurred. A temporary attractive force will be happened or develops. So that force is called London forces. So London forces are also known as temporary forces. So these temporary forces are always attractive. So and they are short range forces, and they are also short range forces. So the interaction energy is always inversely proportional to the sixth power of the distance between the two interacting molecules. So F is directly proportional to 1 by R6. So here R is nothing but distance between the particle. And here these forces are important only at short distance, and their magnitude depends on the polarizability of the particle. Simply, London forces depends on polarizability of the particle. So this is about London forces. Next comes to dipole forces. So dipole forces will be present between two molecules with permanent dipole. That means it occurs between two polar molecules. So what do you mean by polar molecules? When two atoms do not share electrons equally in a covalent bond are called polar molecules. So example, I have taken these polar molecules. So look at here, hydrogen have a bond with fluorine, and here this is hydrogen bond. We already discussed in previous class. Okay, so this is having attraction between fluorine and hydrogen. So here it is more electronegative, that is why it is partially negative. It is electropositive, that is why it is partially positive charge. It acquires partially positive charge. Same here. So here what is happening? This partial negative charge attracts the electrons towards itself, isn't it? So here the dipole forces between the molecules possess a permanent dipole. It possesses a permanent dipole. That means the electron moves towards the highly electronegative particle or an atom. And one thing we have to notice that the partial charges are always less than the unit electronic charge. So what I said, partial charges are always less than the unit electronic charge. Electronic charge means electron charge. So what is electron? How much is electron charge? It is 1.6 into 10 to the power minus 19 coulombs. So the partial charges will be less than that. So look at this example. So here hydrogen have a bond with fluorine, and this is hydrogen bond. Again fluorine have a bond with hydrogen and fluorine. So this, okay, partially negative and partially positive, this block, if you see, their dipole forces will be developed. Okay, these dipole forces are stronger than London forces. They are stronger than London forces. The attractive force decreases with increasing in the distance between the dipoles. The attractive force decreases with increasing the distance between the dipoles. And here, okay, look at here. So this one is called dipole forces. What do you mean by dipole forces? It occurs between the polar molecules. So here we cannot see the equal distribution of electrons. It is having more electronegative, it is more positive, isn't it? So how they will move? They move towards this. Isn't it? Here also they move towards this. So dipole forces will be developed. They are stronger than London forces and they are short range forces. So here the interaction energy. Here the interaction energy is inversely proportional to the distance between the polar molecule. That how much? Force is directly proportional to 1 by 6, 1 by R6 when the molecules are rotating polar molecules, and when force is directly proportional to 1 by R cube when the molecules are stationary. Okay, when the molecules are stationary polar molecules. When it is rotating, the interaction, okay, interaction energy will be this. When they are stationary, when they are not moving, then the energy will be this, the force. Example here, hydrogen bonding. Next comes to dipole induced dipole forces. Dipole induced dipole forces. So this type of attractive forces operate between polar molecules having permanent dipole moment and the molecules lacking permanent dipole moment. So look at here. This type of force will be present between which is having a permanent dipole. Dipole is nothing but which is having partial positive, partial negative charge, and the between, okay, the interaction between non-polar molecule. Here it is not having any dipole, okay, it is not having any dipole moment. So here two molecules we have taken, that is permanent dipole, non-polar molecule. So here a permanent dipole which is also known as a polar molecule. So we can simply say dipole induced dipole forces will be occurred between a polar molecule and a non-polar molecule. So this we have taken a polar molecule which is having partial positive, partial negative charge. So the partial negative charge means it will be more electronegative. So it pull electron towards itself from here to here, from A to B. So here, so look at here children. So a permanent dipole polar molecule induces a dipole on an electrically neutral molecule, deforming the electronic cloud. So what happens? So when they induce some energy here, thus an induced dipole will be developed in the other molecule. So here also induced dipole will be developed in a non-polar molecule. That means here minus charge is there. So here it acquire positive charge. So when here it is positive, it will be minus charge. So it acquires such kind of energy. Understand children? So in this case also the interaction energy, okay, is proportional to 1 by R6, where R is the distance between the molecules, isn't it? And this type of force is also a short range force. So this is about the three types of van der Waal forces. Next comes to thermal energy. So look at here children. Here thermal energy. Thermal is nothing but heat. So we are talking about heat energy. So here I have drawn a diagram. So take a bowl, keep some water and keep it on a Bunsen burner. What happens? When they acquire some amount of heat energy, the water will start boiling. So when it start boiling, the molecules what are present, they move randomly, right? They move randomly. Why? Because they acquire some amount of energy. So here before, what happens here? Intermolecular force. intermolecular force here which is very stronger. When you apply some energy, heat energy, then intermolecular force, what happens here? It will be decreases. Why? Because the molecules are moving. Due to that some heat energy, due to that some thermal interaction will takes place. Okay, thermal interaction. That means here the molecules which acquire some heat energy. When they acquire heat energy, what happened? They move. Okay, they move or they hit to this container. So they randomly move. So intermolecular force. So when you apply some amount of heat energy, so how the intermolecular force versus thermal interaction? How intermolecular force versus thermal interaction? With a simple example, I will explain you. If intermolecular force increases, so the molecules before it will be like this. After that, what happens? They come closer and again they tightly packed. So here, when intermolecular force increases, the gaseous. So here the gas which is vapor state, okay, this when intermolecular force go on increasing, what happens? It changes to a liquid state. Gases to a liquid state. Yes. So when this liquid state, if go on the intermolecular forces increases, the liquid state will be changed to a solid state. Understood, children? So for example, any vapor, if you take this boiling water only, if you keep a plate over it, okay, if a lid, what happens? This water vapor will touch to the plate, and when you remove that lid, the condensation takes place and water droplets you can see. So gaseous change will changes to a liquid when intermolecular forces increases. Okay, next what happens? If that water, if you keep it in a fridge, what happens? It can be solidified, isn't it? So gases to, when intermolecular force increases, the states of matter changes from gas to liquid, liquid to solid. Yes. If thermal energy increases, if you supply more amount of energy, what happened? The solid, first the solid will be changed to liquid, liquid will be changed to gaseous state, isn't it? If thermal energy increases, in a reverse way, in a reverse direction, from solid to liquid, liquid to gas. Yes. So this is the interaction or the difference between the intermolecular force and the thermal interaction. So this is the topic. So far we have completed, and in the next class we are going to discuss the gaseous state. So today's chapter we have learned what do you mean by thermal energy, and what are the three types of what are London forces, and what do you mean by polar non-polar molecule, what do you mean by intermolecular and intermolecular forces and intramolecular forces. So in next class we will start the next subtopic, that gaseous state from this chapter. Okay children, thank you.